This is the second video detailing the real transformer. And as before, it might seem like we're jumping into the middle of a course lesson because it is also an extract from my course on transformers. The fundamental takeaways are still worthwhile reviewing. However, for more details, visit my stand store where all of my courses reside and zero in on the one entitled Electric Three-Phase Power Transformer Fundamentals. You can access my stand store at this web address.
The losses that occur in a transformer have to be accounted for in an accurate model of transformer behavior. This model would have to include copper or I²R losses. Copper losses are the resistive heating losses in the primary and secondary windings of the transformer. They are proportional to the square of the current in the windings. Eddy current losses. Eddy current losses are resistive heating losses in the core of the transformer. They are proportional to the square of the voltage applied to the transformer. Hysteresis losses. Hysteresis losses are associated with the rearrangement of the magnetic domains in the core during each half cycle. They are a complex nonlinear function of the voltage applied to the transformer. Leakage flux. These are fluxes which escape the core and pass through only one of the transformer windings. These escaped fluxes produce a self-inductance in both the primary and secondary coils. In order to make the calculations required of a real transformer, we simply use an ideal transformer with add-ons that, when added to the circuit, produce the equivalent results. This is known as the equivalent circuit of a transformer. Modeling the copper losses or resistive losses in the primary and secondary windings of the core are represented in the equivalent circuit by R1 and R2. Modeling the primary and secondary leakage flux are represented in the equivalent circuit by L1 and L2. The core excitation is modeled by Lm, and the core eddy current and hysteresis losses are modeled by Rc. The bare symbol for a transformer gives no indication of the phase of the voltage across the secondary. The phase of that voltage depends on the direction of the windings around the core. In order to solve this problem, polarity dots are used to show the phase of the primary and secondary signals. The voltages are either in phase or 180 degrees out of phase with respect to the primary voltage. Dots are used to indicate the points in the transformer schematic symbol that have the same instantaneous polarity, points that are in phase. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. One of those products is the EcoFlow Delta Pro Ultra. The EcoFlow Delta Pro Ultra is one of the most versatile whole home backup solutions that has just been introduced to the market. This backup power system is designed for both extended outages and daily use, with the unrivaled capacity of 6 kilowatt hours and 7,200 watts output, and 5.6 kilowatt solar input. A single unit can run your entire home. With EcoFlow Smart Home Panel, you get an uninterrupted power supply backup, and with automatic switchover, energy consumption monitoring, and lower electricity bills. This unit is not driven by gas or diesel generation, but uses the battery storage unit that is charged when the utility is available. This means that the unit can be placed indoors or outdoors and is virtually silent when operating. It has a stackable design that can be expanded to increase output in only minutes, compatible with various energy sources from solar to gas to meet your ever-changing power needs. To attain a discount of 5% off of all 𝐃𝐈𝐒𝐂𝐋𝐀 products and more information on this subject, and to pick up your free digital copy of the Ultimate Guide to Residential Standby Generators, simply fill out the information requested when you go to this website, https://bit.ly/3 lowercase u, uppercase w, lowercase v, lowercase e, uppercase r, and lowercase h. Before we end this video, I want to repeat the connection to my free copy of the Ultimate Guide to Residential Standby Generators and the 5% discount code for all 𝐃𝐈𝐒𝐂 products. Also, here is the connection to obtain a free copy of my 50-page electrical power crib sheets. And finally, here is the link to all of my electrical courses, which are located in my stand store.